Name the plane represented by the front of the box. Well, let's see. First of all, let's identify all the points that are on that surface. It appears that B is in the corner there, F is there, so is J right there, and K, and C, and G. Now remember, we're not allowed to name collinear points, so we can't name, uh, we couldn't name those three, B, J, C, so it couldn't be that because they are all in the same line, and to name a plane, you can't have collinear points. Okay, we couldn't use these three, F, K, and G, for the same reason. Okay, but we need to have some combination of B, J, C, F, K, and G. So CAB, looking at the first one, CAB. Nope, those don't all land on the same plane. A is in the back, right back there, so that doesn't work. G, B, F, G, F, and B. Yeah, those are three that are there. Check it out. G, F, and B. They're non-collinear and they're all in that plane. That's looking like the one, but let's just eliminate the final answer. D, B, F. See, D is in there in the back. That's not on that front surface. So we're talking about three non-collinear points on the front surface, and those are G, B, and F. So that's a good answer for that. Okay? And now, what is the name of three planes that contain point A? This is a great question, okay? Because you can see plane this, okay? A, B, D, C. You could call it that. You don't need to name all 4 points, but you could call it that, A, B, D, C, okay? What else? Well, we can also see it on plane A, B, E, F, or A, B, F, E, or some combination of them, which is the plane that's the back side of this, okay? A, B, E, F, or A, B, F, E right there, A, B, F, E, okay? You can also see it on the left-hand side here, A, C, E, G, A, C, E, G, okay? But they also give us the option of this, and I'm going to erase those three sides that we can see, like where they're traced out with the box lines, right? Okay, and take a look at where the other planes are. First of all, I'm going to look at A. AC is connected here, and HF are down here. There is a plane that runs diagonally through this. If you took that, remember my Space Samurai, and you slice this box, hitting it right here and slicing at this angle straight down through there, there's a plane that runs like this, a surface that runs, and let me see if I can better draw it. Okay, that runs from there to there, runs from there to there, and it's basically that plane cutting it at an angle. That's that right there, okay, and that works. So let's just look at the other ones to eliminate it. First of all, oops, let's see what else there is. CDHG, that's this front plane. Oops, that's this front plane. Point A is not on it, it's in the back, so it's not going to be that one. What else? ACHF. ACHF, yeah, we figured that one out in pink earlier. That works for this and works for this. But what about CDHG? We already eliminated that on B, and we're going to eliminate it on this one as well. On C as well. And then EFGH, that's this plane on the bottom. That doesn't work for this one. So the only one that works is A. And this is something that gave a lot of people trouble, because what you need to imagine is that there are planes there that are not illustrated. There's not just the planes that are the surfaces of the box, but there's all these other ways that you could cut the box with a sword. that would create a plane and go through some of the points. And again, one of them, specifically the one that we want you to see, is the one that slices right through here, diagonally through the box, essentially cutting along from here to here and from there to there and creating that surface right there at an angle. Okay, so that's why A is the answer, and that one's a little bit challenging for people. I've had a lot of questions about that over the years. So good luck with that. Try to imagine that. There's planes everywhere, including in surfaces that you don't